Hello everyone, welcome to Infinity Learn by Sri Chaitanya, and in this session I'm going to discuss your physics paper of weekend test. So let's start with the first question. A moving body collides elastically with another body of equal mass at rest. Then a part of the energy is dissipated as heat. Momentum is conserved, but kinetic energy is not conserved. Both masses start moving with the same velocity, and a moving mass transfers whole of its energy to the mass at rest. Okay, so let's see which of the following option is correct. Body of mass m is moving with some velocity v, and another body, similar body of mass m, is at rest. And the nature of the collision is elastic. That means if similar bodies collide with each other elastically, what happens? They exchange their velocities. So after collision, the second body will gain velocity v and the first body will be at rest. Fine. So what is happening over here? First body is transferring its entire energy to the second body. That means option 4 is correct. The moving mass transferred whole of its energy to the mass at rest. Next is question number 2. A ball of mass m approaches a ball of mass capital M. So this is ball of mass m, and the speed of the mass is given as 4 meter per second. Speed of the ball towards the ball is given as 1 meter per second. Right. The speed of the ball after an elastic collision with the wall is. So let's assume that this direction is negative direction and this direction is positive direction. So speed of this mass m1 after, let's assume that collision is v1. So v1 can be written as m1 minus m2 into u1 divided by m1 plus m2 plus 2m2 u2 divided by m1 plus m2, where m1 is small m and m2 is capital M. Now, if small m is much greater than much less than capital M, then you can write small m minus m is equals to minus m approximately, and small m plus m is approximately capital M. Right? So v1 will be minus m u1 divided by m plus 2 capital M u2 divided by m. Right? So it will be minus u1 plus u2. u1 is 4. So it is minus 4 plus u2 is minus 1 into 2. This is 2 times u2. So it will be minus 6 meter per second. Minus sign over here shows that the ball will move away from the wall at the rate of 6 meter per second. So correct answer is option 4. Next is question number 3. Two spheres A and B collide. If the momentum of A is doubled in the collision, then initial momentum of A and B are equal. Can't comment on this, right? Because initial velocity is not known. The initial momentum of A is greater than that of B. The initial momentum of B is double that of A, and the total momentum of A and B is constant. So in any type of collision, total momentum is conserved. So yes, for sure, the total momentum of A and B is constant, which is option 4. Next one is question number 4. A perfectly elastic ball P1 of mass m moving with velocity v collides with 3 exactly similar balls lying on a smooth table. That means these 4 balls are identical balls, and the nature of the collision is elastic. So we need to find the velocities of the 4 balls after the collision. So see, when the nature of the collision is elastic and two identical objects are colliding with each other, after collision they exchange their velocities. So after collision, the velocity of P2 will be v and velocity of P1 will be 0. Fine. Now P2 will collide with P3. So again they will exchange their velocities. So after collision, velocity of P3 will be v and P2 velocity will be 0. P3 will collide with P4. So after collision, there will be exchange of velocities. So after collision, P4 will gain velocity V and P3 will be at rest. So after all the possible collisions, velocity of P1 is 0, velocity of P2 is 0, velocity of P3 is 0, and velocity of P4 will be V. So correct answer is 0, 0, 0, comma V. So option 3 is correct. Next is question number 5. Two perfectly elastic particles A and B of equal masses traveling along the line joining them with velocity 15 meter per second and 10 meter per second collide, respectively collides. So we have equal masses A and B. One is moving with 15 meter per second and other one is moving with 10 meter per second, and these two particles are identical and the nature of collision is elastic. So again, after collision they'll exchange their velocity, and velocity of A after collision will be 10 meter per second and velocity of B after collision will be 15 meter per second. So correct answer is option 3, 10 and 15. Question number 6. A ball of mass m moving with velocity v vector collides head-on elastically with another of the same mass m but moving with velocity minus v vector. After collision, the velocities are exchanged between the balls. Both the balls comes to rest. Both of them move at right angles to the original direction of motion, and one ball comes to rest and the other ball travels back with velocity 2v. So again, elastic collision, identical balls. So what will happen? They'll exchange their velocities. So correct answer is option 1. Question number 7. When a drop splits up into a number of drops, what will happen, bachcho? Area decreases, volume increases, energy is absorbed and energy is liberated, right? So in this case, energy will be absorbed. Why? Because of the splitting into number of drops. It will require some energy in order to split itself into number of drops. So correct answer is option 3. Energy is absorbed. Question number 8. A square wire frame of side L is dipped in a liquid. On taking out, a membrane is formed. If the surface tension of the liquid is T, the force acting on the frame will be. What is the force, bachcho? Force is equal to surface tension into total circumference, right? So surface tension is T and into total circumference. So one layer will be upwards and other layer will be downwards, right? So total circumference will be 2 times. We need to count for two surfaces. So it will be 4L. So it is 8TL, which is equals to option 3. Next question is question number 9. A wire of length L meters made of a material of specific gravity rho is floating horizontally on the surface of water. If it is not wet by water, the maximum radius of the wire up to which it can continue to float is. So basically it is floating. So net force on it should be 0. So surface tension of the water is T. So T into 2L should be mg, right? M is density into volume. So rho is the density, volume will be it's pi r square into L into G, right? So using this equation, you can write r square as T into 2L divided by rho pi L into G. L will cancel this L. So r square is 2t divided by rho pi g, and r will be square root of 2t upon rho pi g. So correct answer for this one is option 1. Question number 10. A thin wire ring of radius 2.5 centimeter rests flat on surface of a liquid. The pull required to raise the ring before the film breaks is 31.4 into 10 power minus 3 Newton more than it is after. The surface tension of the liquid is. So basically pull required is 31.4 into 10 power minus 3 Newton, right? And this is equals to what? Tension into 2 times the total circumference, है ना? So basically this will be 31.4 into 2 10 power minus 3 is equals to surface tension is not known into 2 times it is 2 pi r. Why? Because it will have two surfaces. So it is 2 times 2 pi r, 2 pi r. So r is given as 2.5 centimeter. If you put the value of r as 2.5 divided by 100, you'll get your surface tension as approximately 100 into 10 power minus 3 Newton per meter. I hope this is clear. So correct answer is option 2. Next is question number 11. A liquid drop of diameter d breaks into 27 drops. Find the resultant change in energy, and T is the surface tension of the liquid, right? So a change in energy will be equal to work done, and that is equal to 4 pi r square n power 1 by 3 minus 1 into surface tension, right? So 4 pi r square is what? Diameter by 2 whole square, so it is d square by 4. N is 27, so 27 power 1 by 3 minus 1 into surface tension. So this will be pi d square into 2 t. So 2 pi d square t is the correct answer for change in energy, which is equals to option 1. Next is question number 12. Radius of a soap bubble is increased from R to 2R. Work done in this process in terms of surface tension is. So again, work done is equal to surface tension into change in area, right? So surface tension is S, area. This is of soap bubble. So it will be 2 times 4 pi r2 square minus r1 square. So it will be 8 pi s 2r whole square minus r square. So it is 3r square into 8 pi s. So this is 24 pi r square s, which is option 1. Question number 13. In SI system, the total energy of free surface of a liquid drop is 2 pi times the surface tension of the liquid. The diameter of the drop is. So surface energy is given as S into A, and it is given as 2 pi S, right? So surface area over here will be 2 pi. Surface area is nothing but 4 pi r square, and it is equals to 2 pi, right? So basically r square will be 1 by 2. So r will be 1 by root 2 meter. Diameter will be 2 times radius. So it will be 2 times 1 by root 2 meter. So it is root 2 meter, which is option 1. Option 2. So correct answer is option 2, root 2 meter. Next is question number 14. The work done in increasing the size of a rectangular soap film of dimension 8 centimeter into 3.75 centimeter to 10 centimeter into 6 centimeter is 2 into 10 power minus 4 joule. The surface tension of the film is. So again, बच्चों, surface tension into delta T is equals to what? Work done, that is 2 into 10 power. Surface tension into delta A is 2 into 10 power minus 4, right? So it will be 2T into delta A. We are talking about the soap film, right? So it will have two surfaces. Okay, so delta A is 10 into 6 minus 8 into 3.75, and it is in the centimeter square. So we need to multiply it with 10 power minus 4 to make it into meter square. So this is 2 into 10 power minus 4. So by solving this equation, you'll get the value of surface tension as 3.33 into 10 power minus 2 Newton per meter, which is option 2. Question number 15. Which graph represents the variation of surface tension with temperature over small temperature ranges of water? So ST is equals to S naught into 1 minus alpha T. So you can see that this is linear graph. So 1 and 4 are not possible. Now with increase in the temperature, ST will decrease because it is 1 minus alpha T. So we have only one possible answer, which is option 2. Question number 16. For a surface molecule, the net force on it is 0. There is a net downward force. The potential energy is less than that of the surface molecule inside, that of a molecule inside, and the potential energy is more than that of a molecule inside. So basically, surface molecule has net downward force, right? And that is why it experiences surface tension, and the potential energy will be more as compared to the bulk molecule, right? So correct answer is both B and D are correct, which is option 4. Question number 17. Several spherical drops of a liquid of density D and radius R coalesce to form a single drop of radius R. If all the energy released is converted into kinetic energy, then the velocity acquired by the drop is. So basically, all the energy released. So energy released will be surface tension into change in area. So it is 4 pi r square into, this is for drop, so it is n power 1 by 3 minus 1 into T is equals to what? Half mv square, but mass is density into volume, so it is D into volume is 4 by 3 pi r cube. That this is for a single drop, right? Bigger drop, and into V square. So basically 4 pi will cancel this one, and r square will cancel this r square. So we have n power 1 by 3 minus 1 into surface tension is equals to 1 by 6 d v square into r, right? Now we know that uh, capital R is n power 1 by 3 into small r, right? So you can write n power 1 by 3 as capital R divided by small r. So it will be capital R divided by small r minus 1 into tension is equals to 1 by 6v d into v square, and you can divide it by r, right? So it will be 1 upon r minus 1 upon capital R into t, 6 divided by d is equals to v square. So if you take the square root on both the sides, you'll get your value of velocity, that is square root of 60 upon d into 1 minus r upon 1 minus capital R, which is option 1, right? Next is question number 18. In the elastic collision of a heavy vehicle moving with a velocity of 10 meter per second and a small stone at rest, the stone will fly away with a velocity equal to. This is the special case of elastic collision. When the heavy particle strikes the smaller particle, what will happen? Heavy particle will not change its velocity, but the smaller particle will move with double the velocity of the heavier particle. So stone will move with the velocity of 2 into 10, that is 20 meter per second, and the correct answer is option 3. Question number 19. A moving mass of 8 kg collides elastically with a stationary mass of 2 kg. If E with the initial kinetic energy of the moving mass, the energy left with it after the collision will be. So basically energy left after the collision can be given by m1 minus m2 divided by m1 plus m2 whole square into E. These are the shortcuts that you should remember, bacho. So 8 minus 2 divided by 8 plus 2, that is 10 whole square into E. So it is 6 upon 10 whole square into E, which is 36 upon 100 into E. So it is 0.36 E, which is option 3. So this is the kinetic energy left after the collision, which is option 3. Next is question number 20. A billiard ball moving with velocity 5 meter per second collides with the identical ball originally at rest. If the first ball stopped dead after collision, then the second ball will move forward with the speed of. So basically, identical balls are colliding with each other, right? So what will happen? In the case of elastic collision, both the balls will exchange their velocities, right? So 5 meter per second will be given to the second ball and 0 meter per second will be given to the first ball. So second ball will move with a velocity of 5 meter per second, which is option 2. Question number 21. If a ball of mass m elastically collides against a wall with a velocity v and returns in the opposite direction with the same velocity, what is the change in momentum? So this is wall. Initial momentum will be mv. Final momentum will be minus mv, because it is changing its direction, and momentum is what? A vector quantity. So change in momentum will be minus mv, final minus initial, so it is minus 2 mv. So magnitude of change in momentum will be 2 mv, which is option 3. Question number 22. Which of the following statements is correct? Kinetic energy and momentum both are conserved in all types of collision? No. Kinetic energy is conserved in the case of elastic collision only. So this is wrong. Total kinetic energy is not conserved, but momentum is conserved in inelastic collision? Yes. Momentum is conserved in all the types of collision, but kinetic energy is conserved only in the case of elastic collision. So correct statement is option 2, right? Let's talk about 3 and 4 also. Momentum is conserved in elastic collision but not in inelastic collision. No, momentum is conserved in all the types of collision. Total kinetic energy is conserved in inelastic collision, but momentum is not conserved. No, momentum is conserved, kinetic energy is not conserved in inelastic collision. So correct answer is option 2. Question number 23. If two masses m1 and m2 collides, the ratio of change in their respective velocities is proportional to. So let's say this is m1 with initial velocity u1, this is m2 with initial velocity u2. So initial momentum will be m1 u1 plus m2 u2. This is mass m1 after collision with velocity v1. This is mass m2 after collision, its velocity is v2. So final momentum will be m1 v1 plus m2 v2. So momentum is conserved, right? So m1 u1 plus m2 u2 is equals to what? m1 v1 plus m2 v2. So you can write minus m2 v2 plus m2 u2 is equals to m1 v1 minus m1 u1, right? So minus m2 common, so it is v2 minus u2, and m1 common, so it is v1 minus u1. So v2 minus u2 is the change in velocity of m2, and v1 minus u1 is the change in velocity of m1, right? So v1 minus u1 divided by v2 minus u2 will be minus of m1 upon m2. So ratio, it's directly proportional to what? m1 upon m2, m2 upon m1. Sorry, this is m2 divided by m1, m2 upon m1. So correct answer is option 3. Question number 24. A collision doesn't require physical contact. Yes. Collision between subatomic particles is elastic. Yes. Collision between macroscopic bodies is generally inelastic. So all these three statements are true. So correct answer is option 3. A, B and C are true. Like in electrostatic force, collision is the event which can change the momentum of the bodies, right? So without contact, you can also change the momentum of the body with non-contact forces. Collision between subatomic particles is considered as elastic, and collision between macroscopic bodies is generally inelastic. So all these three statements are what? True. So correct answer is option 3. Question number 25. For any collision, momentum transfer takes place. Okay. In any collision, energy transfer takes place. Impulsive forces are involved in collision. So yes, impulsive forces are involved in the collision, and for any collision, momentum transfer takes place. We can't comment about the energy, but yes, option A and C are true. So correct answer is option 1. Question number 26. A sphere A impinges directly on the identical sphere V at rest. So basically, we have a sphere of mass m and we have another sphere V of mass m, and let's say it is moving with velocity u. It directly collides with this identical sphere and the coefficient of restitution is E. Then the ratio of velocities of A and B after collision will be. So let's say velocity of A after collision is v1 and velocity of B after collision is v2, right? What is the initial momentum? Mu. What is the final momentum? Mv1 plus Mv2. Now, according to conservation of momentum, Mv1 plus Mv2 is equals to mu, right? So v1 plus v2 is equals to u. So this is our first equation. v1 plus v2 is equals to u. Coefficient of restitution is given as velocity of separation divided by velocity of approach. So this will be v2 minus v1 divided by u. So v2 minus v1 is equals to eu. And at the same time, we have v2 plus v1 is equals to u. Let's add this two equations. So you get 2v2 is equals to e plus 1 into u. So v2 will be e plus 1 into u divided by 2, right? Now, if you put the value of v2 in this equation, you'll get v1 that is equals to 1 minus e into u by 2. So ratio of v1 to v2 will be 1 minus e divided by 1 plus e, which is option 1. Question number 27. A ball moving with velocity 2 meter per second collides head on with another stationary ball of double the mass. If the coefficient of restitution is 0.5, then their velocities in meter per second after collision will be. So we have a ball of mass m. It is moving with 2 meter per second. It collides with head on with another stationary ball of mass 2m, right? Okay, and the mass is double. If the coefficient of restitution is 0.5, which is 1 by 2, then their velocities after collision will be. So m, let's say, is moving with velocity v1 after collision, and 2m is moving with velocity v2 after collision, right? So according to conservation of momentum, 2 into m, initial momentum, is equals to mv1 plus 2mv2, right? So it will be v1 plus 2v2 is equals to 2. We have our equation number 1 with us. Second equation can be written in terms of coefficient of restitution, which is velocity of separation divided by velocity of approach. So this is v2 minus v1 divided by u. है ना? So v2 minus v1 is equals to 1. This is second equation, right? So v2 minus v1 is equals to 1. Let's add this to equation. So we have 3v2 is equals to 3. So v2 is equals to 1 meter per second, right? Now if v2 is 1, then v1 will be v2 minus 1, and that is equals to 1 minus 1, which is 0 meter per second, right? So v1 is 0 and v2 is 1. So correct answer will be option 2. Question number 28. A ball is dropped from a height h onto a floor and rebounds to a height h by 16. The coefficient of restitution between the ball and the floor is. So, height gained by the particle after the nth rebound will be small h is equals to e power 2n into capital H. So, basically, small h is h by 16, capital H is h. So e square is given as 1 by 16. So e will be 1 by 4. So coefficient of restitution in this one is what? 1 by 4, which is option 2. Question number 29. A particle falls from a height h upon a fixed horizontal plane and rebounds. If e is the coefficient of restitution, the total distance traveled before rebounding has stopped is. So basically it will fall from a h height. After rebounding, it will gain a height of e square into h. It will come back with the same height. Then after next rebound, it will gain a height of e power 4 h. Okay. Then it will come back to the next from the same height, e power 4 h, and so on, right? So basically, the total distance will be h plus e square h plus e square h plus e power 4 h plus e power 4 h up to so on. So h plus e square h, you can take h common, 2h common, because everything is 2 times. You can write it as h plus 2 e square h plus 2 e power 4 h and so on, right? So 2h can be taken as common, so it will be e square plus e power 4 and so on. So this is your infinite GP, so this will be h plus 2h, and the summation of infinite GP is a upon 1 minus r, so it is e square upon 1 minus e square. So you can take h common, so it will be 1 plus 2 e square upon 1 minus e square, which is 1 plus e square upon 1 minus e square into h, right? You can directly remember this result if you want, because this one is very important. So correct answer is option 1. Next question is question number 30. For inelastic collision between two spherical rigid bodies, the total kinetic energy is conserved, total potential energy is conserved, the linear momentum is not conserved, and the linear momentum is conserved. For any type of collision, linear momentum is always conserved, but kinetic energy is conserved in the case of what? Only in the case of elastic collision. So correct answer is option 4. Question number 31. Two balls of 5 kg and 10 kg are moving towards each other with speed 16 meter per second and 8 meter per second respectively. If after collision they combined, then the common velocity of the system is. So initial momentum will be, 5 kg is moving with 16 meter per second in this direction and 10 kg is moving with 8 meter per second in this direction. So net momentum is 5 into 16 minus 8 into 10, which is equals to 0. So final momentum should also be 0 because of the conservation of momentum. If these two particles combine with each other, what will happen? Total 15 kilogram mass with, let's say, move with velocity v. So final momentum will be 15v and it should be 0. That means v should be 0. So after collision, the common velocity of the mass will be 0, which is option 4. Question number 32. A bullet of mass m is fired with velocity v onto a block of wood of mass capital M and initially at rest. The final velocity of the system will be. So basically we have a block of mass capital M. Bullet is fired of mass m with some velocity v. So initial momentum will be mv. After collision, the total mass of the system will be small m plus capital M. Let's say it is moving with v dash. So final momentum will be small m plus capital M into v dash. So initial momentum is equals to final momentum. So mv is equals to m plus m into v dash. So v dash will be mv divided by m plus m, and that is equals to option 1, right? Next is question number 33. A neutron moving with velocity u collides elastically with an atom of mass number a. If the collision is head-on and the initial kinetic energy of the neutron is E, then the final kinetic energy of the neutron after the collision is. So basically kinetic energy left will be m2 minus m1 divided by m1 plus m2 whole square into initial energy E, right? You can always remember the shortcut. So it is A minus 1 upon A plus 1 whole square into E. So correct answer is option 2. Question number 34. A stationary particle explodes into two pieces of masses m1 and m2 which move in opposite directions with velocities v1 and v2. The ratio of their kinetic energies will be. So basically we have a stationary particle, so its momentum will be 0. P initial is 0. So after explosion, the combined momentum of this system should be 0. That means this particles should move in the opposite direction so that they can cancel each other's momentum, right? So m1 v1 minus m2 v2 should be 0. So m1 v1 is equals to m2 v2, which is the momentum of individual particle. So numerically, the value of momentum of individual particle should be equal. Direction must be opposite, but the numerical value should be equal. So basically, kinetic energy is given as p square upon 2m. Right. So kinetic energy is inversely proportional to mass. So K1 upon K2 can be written as M2 upon M1, which is option 3. Question number 35. A sphere has a elastic oblique collision with another identical sphere which is initially at rest. So we are talking about the elastic oblique collision with the same type of body, identical body. So angle between the velocity after the collision must be 90°. So this question is based on information. You can always remember this information that the angle must be 90°, which is option 4. Question number 36. A particle of mass m moving eastward with a velocity v collides with another particle of the same mass moving northward with the same velocity v. So basically we have two masses m. It is moving with velocity v in this direction. Another mass m moving with velocity v in this direction. So what is the initial momentum of the system? mv I cap plus mv j cap. Now, after collision, both of these particles combine and they move with a common velocity. So, common velocity will be, let's say, v dash, right? Vector. So, final momentum is equals to initial momentum. So, 2mv dash vector will be the final momentum and it must be equal to initial momentum. M will cancel m. So, we have v dash vector as v by 2 I cap plus v by 2 j cap. So, magnitude of v dash vector will be under root of v square by 4 plus v square by 4, which is v square by 2 square root. So, it will be v upon root 2, which is option 3. Question number 37. A metal ball of mass 2 kg moving with the speed of 36 km per hour has a head-on elastic collision with a stationary ball of mass 3 kg. If after collision both the balls move together, then the loss in kinetic energy due to collision is. So, loss in kinetic energy due to collision is given by half m1 m2 divided by m1 plus m2 into u1 minus u2 whole square. u1 is 36 kilometer per hour. Let's convert it into meter per second. So it will be 10 meter per second, and u2 is given as 0. So it will be half 2 into 3 divided by 2 plus 3 into 10 minus 0 whole square. So the value of loss of kinetic energy due to collision is equal to 60 joules, which is option 2. Question number 38. A sphere of mass m moving horizontally with velocity v naught collide against a pendulum bob of mass small m. If the two masses stick together after the collision, then the maximum height attained is. So maximum height attained is u square upon 2g. Let's find the value of u. Sphere is moving with velocity v naught. It collides with this pendulum of the same mass m, right? So initial momentum is mv naught. Let's say after collision both of these masses stick together. So after collision velocity is u. So 2mu is the final momentum. So initial momentum is equals to final momentum. So u is v naught by 2. Right, let's put the value of u in this one to get the value of height attained. So it is v naught by 2 whole square divided by 2g. So it is v naught square divided by 8g, and that is your option 4. Question number 39 is a ball impinges directly upon another ball at rest. So we have a ball of, let's say, mass m1. It is moving with velocity u1, and we have another ball of mass m2 which is at rest. So initial momentum will be m1 u1. Now, after impact, ball 1 is brought to rest. So, ball 2 will gain some energy. Let's say its velocity is v2. And if half of the initial kinetic energy is destroyed in the collision, the coefficient of restitution is. So, final momentum will be m2v2. According to conservation of momentum, m1u1 is equals to m2v2, right? Initial kinetic energy will be half m1 u1 square, and half of this kinetic energy is converted into the kinetic energy of m2. So you can write half m2 v2 square is half of half m1 u1 square. So using this equation 2 and this equation 1, you can find the ratio of v2 by u1. So let's find it out. So we have m2v2 which is equals to m1u1. So I'm putting m2v2 into v2 as half m1u1 square. m2v2 is m1u1. So it is m1u1 v2 is equals to half m1u1 square. So m1 will cancel this m1, u1 will cancel this u1. So basically we have v2 is equals to u1 by 2. Right, coefficient of restitution in this case will be v2 by u1. So v2 by u1 will be 1 upon 2 using this equation. So coefficient of restitution will be 0.5, which is option 3. Question number 40. Two identical balls of equal mass m and masses A and B are lying on a smooth surface as shown in the figure. Ball A hits the ball B, which is at rest, with velocity 16 meter per second. What should be the minimum value of coefficient of restitution between A and B so that B just reaches the highest point of inclined plane? So B should reach here, right? So velocity should be under root 2gh, which is equals to under root 2 into 10 into h is 5. So it is under root of 100, which is 10 meter per second. So after collision, velocity of B should be 10 meter per second. Let's say velocity of A after collision is V. Okay. So according to the conservation of momentum, M into 16 is equals to M into V plus M into 10. Right. So V will be 16 minus 10, that is equals to 6 meter per second. So coefficient of restitution will be velocity of separation, that is 10, minus 6 divided by velocity of approach, that is 16. So it is 4 by 16, that is equals to 1 by 4. So correct answer will be option 2. Question number 41. A mass m moves with velocity v and collides elastically with another identical stationary mass. After the collision, the first mass moves with velocity v by root 3 in the direction perpendicular to the initial direction of motion. Find the speed of the second mass after the collision. So we have a mass m. It is moving with velocity v. It collides with another mass of m and it is at rest. Fine. So after collision, first mass moves with v by root 3 velocity in direction perpendicular. We need to find the velocity speed of the second mass. Fine. So initial momentum will be mv. Let's say it is I cap is equals to final momentum mv by root 3 j cap plus let's say mv vector. So this m will cancel this m. So we have v vector as v I cap minus v by root 3 j cap. So magnitude of this velocity vector will be square root of v square plus minus v by root 3 whole square, which is equals to 2v upon root 3. So speed of the second ball after the collision is 2v upon root 3, which is option 1. Question number 42. A block of mass m moving with speed v naught strikes another particle of mass 2m at rest. If the collision is head on and the coefficient of restitution is 1 by 2, then the loss in kinetic energy will be. So loss in kinetic energy in this type of collision is given as half m1 m2 upon m1 plus m2 into u1 minus u2 whole square into 1 minus e square. So it will be half m into 2m divided by 3m into v naught minus 0 whole square into 1 minus 1 by 4. So it will be m by 3 into 3 by 4 v naught square. So it is 3 m by 4 m v naught square, which is option 2. Question number 43. In an explosion of body breaks up into two pieces of unequal masses. In this, both parts will have numerically equal momentum. Yes, because if explosion is happening, that means initially the body is at rest. So its initial momentum is 0. After explosion, its complete momentum of the system should be 0. That means if one body is having momentum p in this direction, other body should have momentum p in this direction, so that net momentum is again 0. So both the parts will have numerically equal momentum. So correct answer is option 1. Question number 44. When a wire of length L is stretched with a tension F, it is extended by L. If the elastic limit is not exceeded, the amount of energy stored in the wire is half Fl, right? It is directly formula based. So amount of energy stored in the wire will be 1 by 2F into L. Next question is question number 45. A catapult prepared by rubber cord of gamma uh, 5 into y, 5 into 10 power 8 Newton per meter square, length 10 centimeter, and area of cross section is 4 square mm. It is stretched to a certain length and released so that the stone of mass 5 grams comes out of the catapult will have a velocity 40 meter per second. The stretching length of the catapult in centimeter will be. So basically half y e upon L whole square is equals to what? Half mv square, right? So basically E is the stretching, right? So it will be half into 5 into 10 power 8. You can put the value of L, and it is half m, which is 5 upon 1000 into v square, which is 40 into 40. So after solving this one, you'll get the value of E as 2 centimeter, right? 46th question. A thin wire suspended vertically from one end is stretched by attaching weight of 20 Newton to the lower end. The weight stretches the wire by 1 millimeter. How much elastic potential energy is stored in the wire? So it is half Fl. So half F is 20 and F is 1 millimeter. So this is 10 power minus 3. So it is 10 power minus 2 joule, which is equals to 0.01 joule, which is option 1. Question number 47. Between two parallel wires, each of length 10 centimeter, a soap film is trapped. If the separation between them is changed from 2 centimeter to 4 centimeter, still being parallel, then the work done for this is, and the surface tension of soap solution is 50 dyne per centimeter. So work done will be 2 times tension, surface tension into delta A. So this is 2 times 50 into delta A will be 10 into 4 minus 2. So it will be 100 into 20, which is 2000, right? It is in org because all the units are in CGS system. So if you convert it into joules, you'll get your answer as 2 into 10 power minus 4 joules. Question number 48. Let W be the work done when a bubble of volume V is formed from a given solution. The work required to form a bubble of volume 2V is. So basically W is the work done, and this W is given as surface tension into change in surface area, right? So it is for soap solution, it will be 8 pi r square into T. So W is directly proportional to r square, but volume is given as 4 by 3 pi r cube. So volume is directly proportional to r cube, or you can say that r is directly proportional to volume power 1 by 3. So basically work done is directly proportional to volume power 2 by 3. Fine, right? So if you are increasing the volume from V to 2V, work done will be directly proportional to 2 to the power 2 by 3, है ना, into V to the power 2 by 3. So V to the power 2 by 3 is the initial work done. So final work done W dash will be 4 to the power 1 by 3 into W. So correct answer will be option 1. Question number 49. A smooth sphere is moving on a horizontal surface with velocity 2i cap plus 2j cap immediately before it hits a vertical wall. Okay. The wall is parallel to j cap vector and the coefficient of restitution between the sphere and the wall is 1 by 2. The velocity vector of the sphere after it hits the wall is, there will be no impact along x-axis. There will be, yeah. So basically what will happen, because of the impact along x-axis, its velocity will change along x-axis, but there will be no force acting along y-axis. So its momentum will not change. Its momentum will not change along y-axis. So its j cap component will be same, that is 2j cap. And after hitting this wall, it will move in this direction. So its velocity will be minus EU after collisions, which is minus 1 by 2 into U, which is initial velocity along x-axis, which is 2. So it is minus 1. So this is minus I cap plus 2j cap. Right. So correct answer is option 2, minus I cap plus 2j cap. Question number 50. An explosion blows a rock into 3 parts. 2 parts go off at right angles to each other. These 2 are 1 kilogram with 12 meter per second, 2 kilogram which is moving with 8 meter per second, and the third part flies off with a velocity of 4 meter per second. Its mass would be, so basically initial momentum of the rock is 0, right? So final momentum should be 0. So final momentum is 12 into 1 I cap plus 8 into 2 j cap plus m v vector, which is equals to 0. Let's say mass of the third part is m and its velocity vector is v. So basically mv vector is minus 12 I cap minus 12 j 8 16 j cap, right? So magnitude of mv vector will be minus square root of minus 12 whole square plus minus 16 whole square, 20, right? And this is equals to m magnitude of v vector, which is 4. So m will be 20 by 4, that is equals to 5 kilogram. So mass of the third part will be 5 kilogram, which is option 2.